Hey guys, welcome. Today we're going to be looking at geologic history of the region, and this addresses three of the earth and environmental standards that are listed here. But let's go ahead and get started. So this lesson is going to extend past just this lesson. You're going to learn more through the explores and the extends, and really delve into some more information. And then this information will continue throughout the year as we explore as our impact and lots of different things that we're going to learn about in North Carolina. You have probably already learned this, but North Carolina is divided into three physiographic provinces. That is the Coastal Plain, the Piedmont, and the Blue Ridge. And the classes, and we also know that the three major classes of rock are igneous, metamorphic, and sedimentary. And if you don't remember that, you should go ahead and look back at our last lesson on rocks and weathering. All right. North Carolina has a really long and complex geologic history, and we're going to delve into just a very short piece of that, but you'll get to see more of that when you go to your Explorer. All right, so first thing we need to know is we talked that there's these three regions, and in between each of these three regions is what is called a fall zone. All right, and a fall zone is when there is a very short division between rock and soil profiles. So we do see a difference between the soil that we see in the Piedmont and the soil we see in the coastal plain, and there is a very small region called the fall zone where this changes, and it's very short, and you can sort of see here on the right side where that fall zone falls between the coastal plain and the Piedmont. North Carolina is also well known for its barrier islands, which we call the Outer Banks. And barrier islands are coastal landforms that create a barrier system for the coast. And it runs strips of sand that run parallel to the main coastline. So we have some map here that shows you a bunch of the different barrier islands as they run along our shoreline. Now, not all barrier islands look different. They have different formations that they form, and you can learn some of these. You will be learning more of these names. So you have the barrier island, and behind the barrier, you have what's called the back barrier. You have deltas, which you've probably learned before, and bayheads. All right, you will also see salt marshes and tidal flats and tidal bars, and then you'll see ebb deltas, inlets, sounds, shoals. All right, and then when you look out and you're looking under the water, you see areas that are called tows. You see a swash zone and tow elevations, and then you have the shore face and again the back barrier. River basins. So if you think of a bathtub and you're standing in the bathtub and you've got the shower going, all right, the shower, think of the shower as like rainfall. All the water that falls is going to be funneled down to the bottom of the bathtub and pushed down the drain of the bathtub. A river basin is the same, is similar. So what happens is the rain, as it falls, all right, it gets caught in so many different places, in the soil, in streams, in little creeks, and all of that gets funneled into a particular river that then flows out into the ocean. And we call those little bathtub-like regions river basins. Valleys. So we've talked about the formation of mountains, but the formation of valleys is like really dynamic. Yeah. But valleys are formed in many different ways. They can be formed through water flowing, they can through ice and glaciers in the process of erosion, and just a gradual wearing. And it can also happen through wind and water. Just wind can form our valleys. So valleys are a huge landform that we'll look at some in our timelines and see how these valleys were formed just as uniquely as the mountains were formed. All right, so looking at just some recent geologic history in North Carolina. So the last earthquake in North Carolina was in 2011. It was a magnitude 2.1. It was in the very western portion of the state, but you could feel it from Tennessee all the way to Raleigh. But it probably wasn't a very big shake. Eastern coast seismicity. I've mentioned this earthquake before. I was living in Pittsburgh when this happened, and I was sitting in a chair, and I felt like my rolly chair was just moving back and forth, and I looked over at my coworker and I was like, did you feel that, or am I just crazy? But there was a magnitude 5.8 earthquake centered in Virginia. You could feel them as far as North Carolina and as north as Buffalo and Boston, and as far west as Detroit. Of course, earthquakes are much less common on the East Coast than they are on the West Coast, because the East Coast is not a hot earthquake zone these days. And Virginia doesn't sit on an active earthquake fault. But about 200 to 300 million years ago, there were a lot of earthquakes occurring in this eastern United States area. So what caused the earthquake in Virginia? And that is fault scars. Those are left over from time, probably pressure built up, and it's left over from previous earthquakes, and it just happened. But it's not something that's going to regularly happen, but it does happen occasionally. So if we look at earthquake epicenters from 1698 to 1997, you can see all of these epicenters. You see a lot over there in the Blue Ridge in Tennessee, and not quite as many closer to the coast, but they are happening. There are not many major ones, but you will know that there was a major one in Charleston, and that one is recorded and talked about a lot, but it's a lot of little small ones happening in the mountains. All right, so what is our greatest hazard? Of course, you can see here, because of that major earthquake in Charleston, there is a big region there, hot region for seismic hazard, and over in the mountains, but not really a whole lot here where we are in Charlotte. All right, and so I was mentioning that earthquake in Charleston, so let's talk a little bit more about that. It happened in 1886. It was a magnitude 7.3, and it destroyed a whole lot of stuff. And it's the most damaging earthquake to occur in the southeast United States, and one of the largest historic shocks in the eastern North America. It destroyed many of the buildings in Old City of Charleston, and it killed 60 people. And it was felt as far as Boston, Milwaukee, Wisconsin, Chicago, Illinois, Cuba, and Bermuda. All right. All right, so one of the greatest geologic risks here in North Carolina are landslides, because we have mountains, especially up in the mountains. So you see these, and so there's a huge push for stabilization efforts. I've talked about the landslide protection that they have on Interstate 40 heading into Tennessee. But we're also planting vegetation. We're angling slope differently as best as we can. And then there's also soil bioengineering that's happening. And that's something you could really look into, soil bioengineering, in some of your horticulture, animal science, agriculture classes. All right, landslides are also somewhat related to floods. So in 1916, there was a giant hurricane, and in Transylvania County, North Carolina, which is a place, there was some huge landslides and flooding that occurred. And it is the July 15th through 1916 flood is a flood of record in western North Carolina. And you can see a lot of pictures of this and a lot of records of it when you go look in museums in western North Carolina. I remember going to Swain County and seeing records of this flood because it had a huge impact on the Bryson City community. There, for the landslide fatalities in Transylvania County, there was Johnny Heath died in Dunn's Rock, Miss Caldwell Centil and her 7-year-old daughter died in the Davidson River area. All right, and there were landslides in Dunn's Rock, Penrose section, King's Cross, and then from Brevard, you can see scars visible in many directions. And there were 56 plus landslides from this flood. And there's an image of Asheville underwater after this flood. So that same flood transported a boulder weighing 900 tons along the Toxaway River, and because the Lake Toxaway Dam failed. And so it moved it a half-mile downstream, and you can see this boulder. I think this one up on the top left really gives an image of how large this boulder was. And then you have a cross-section down at the bottom of what happened here. And this boulder is holding back floodplain deposits that occurred following that flood. There was also if you look here, there was a large landslide in the Maggie Valley area not too long ago, and this image here it's a more current image, but it shows you the yellow is where the landslide came from, and then the green line is where all that debris fell. So you have the source area, and then you have what's called the debris fan, where all the material flew down, and it came through that little area, that small little area where the yellow and green come together. All right, and this happened in 2003. All right. So when you have high excavations, especially to build houses on mountains and stuff, the cut slope can really fail. And in this case, it got under the log cabin and it pushed it 3 to 5 feet off of its foundation. After that, Maggie Valley landslide, there was a lot of debris. Demolition had to take into effect. So here's an image that shows you what it looked like following that area, that landslide. You can see that there's a very delineated area where the landslide occurred and then where debris is. There are untouched trees, whereas there are areas that are completely destroyed. Some of the ideas they think is there was a water line leaking. What caused it, the leak, they're not sure. But there's really more efforts to protect the land these days.